Let's code.
Today's episode is brought to you by Ixia. Ixia's solutions test, assess, and optimize networks and data centers to accelerate and secure application delivery. Telecom Careers, the industry's largest resume database and job board.
This is Jeff Mucci with RCR Wireless News. Thank you for watching the first episode of Coders, a show about coding by software developers. Today we got two seasoned veterans, but before we introduce them, I want to play you a video of a local developer who's working for a technology company. I think you'll be surprised by what you see.
The LED cycles through.
Abby Audette looks right at home writing code for Silicon Labs.
We use the temp sensor on the MCUs.
But she's not an employee. She's a high school sophomore writing code well beyond her years.
I showed it to some of the more programming-centric coworkers, and they were kind of impressed or really impressed, and I wouldn't tell them that we're talking about a young woman who just finished ninth grade.
Jason Savage, senior manager for product test engineering, discovered Abby last year as part of Silicon Labs' program for young coders.
Abby had already finished the 8th grade when I started the program in 2014, and the GT, gifted and talented teacher that I work with for this program, she told me, you have to meet Abby.
I came to meet and have lunch with Jason, and we were just talking. At that time, it was just kind of going to be like a come visit for a day thing. And then he asked for a sample of my code, so I sent it to him from what I had used for robotics the year previously.
The code started getting circulated to different engineers, and they loved it. And when I would drop the bomb on them and say she's 15 years old, they were saying, what can we do to get her in here to get some more experience?
It turned into a groundbreaking opportunity for Abby. She became the first ever paid high school intern at Silicon Labs.
I wrote demos for one of the MCUs here. And so I was just I met with the marketing team to find out what they wanted from this, and I would have like weekly meetings with my manager, like how's it coming?
Across the board, everyone that met Abby, the work she did, the way she carried herself professionally, most people didn't know she was a ninth grader.
Savage hopes Abby is just the beginning.
Silicon Labs really needs a lot more programming students for the products that we're generating these years.
He believes this program could solve that problem.
What's great about when you try something for the first time like this, when you have success across the board, it sort of opens the doors to do this this summer and many summers from now, and hopefully grow the program where we may have several high school students working here writing code for Silicon Labs.
If those students are anything like Abby, the future looks bright.
It's fun. It's like, wow. So it kind of keeps you motivated. Like if I study hard enough and if I keep with this.
Well, today is our first episode of Coders, and I'm delighted to have two old friends, young old friends, old and new friends, on my show. Number one, we've got Bob Miller. Is a longtime telecom and internet coding professional. Bob is in Lafayette, Louisiana. Bob, thanks for joining us this morning.
Yeah, thanks for having me.
And here in our Austin production studio, we have Ely Compean. Eli and I worked together in 2001. We started a DSL company here in Austin. Eli, thanks for joining us.
Oh, thanks for inviting me.
Pleasure to have you. So let's talk a little bit about that clip we just saw, this young developer. Both of you have run development teams. And my question, and Bob, we'll start with you. You know, how does a manager recognize a good coder?
Yeah, I think the video was kind of interesting because the guys there at Silicon are obviously doing a really good job of understanding when they see something that's kind of special. Because Abby, you know, even when I was watching the clip, you know, I knew right away that she obviously had a passion for what she does and loves to do it and has been doing it a long time. And it was really good that the manager that really wasn't a coder actually kind of circulated some of her work around to some other people who really were good coders, because it doesn't take long for somebody who's programmed for a living to really notice and be able to recognize a talent. So I think they did a really good, he did a really good job of actually spotting that, realizing up front that you don't normally have an 8th grader who's able to do a lot of coding at that level, because she was doing systems level coding on that little interface device that she was working with. And so you just don't see that every day. And when you do, you need to vet that pretty quickly. So that's definitely a way to kind of tell, is if they're just passionate about it. I mean, the one thing you can do is anybody who's a really good programmer, if you just get them started talking about programming, if they just won't shut up about it, then you're on the right track. So, and I got a feeling that Abby would, she'd talk your head off about it. I mean, she just has that look and feel to her. And and obviously loves what she's doing.
Identifying good talent is Josh. Is he still behind you back there? When you and I worked together almost 20 years ago, Josh was part of your team, and he's still with you today. Is that right?
Yeah, I mean, I've worked with Josh through 5 different companies over a total of close to 20 years. I mean, when I first met him, he was 18 years old. So, he was definitely one of those Abby type people that when you meet him, it takes very short amount of time to determine how good he is. And over the years, we've slayed a lot of dragons, no doubt about it. So.
And Eli, you're a developer yourself. You've done a lot of things in telecom and otherwise. What are some of the key things you look for in a young developer?
Well, actually, we have a program, and just recently, we've handed out Raspberries, and we hand it to these young programmers, and we let them see what can be done. It's a small little environment for them, and as Don was just mentioning, if they have a love for it, you're going to show it. They just constantly call me. What do I do here? Why is this working this way? Why is this not working? That's the intuitive. They want to really figure it out, and if they can't, they get frustrated, and they just want to figure it out. They want to develop the code, and it's really unique how elegant those that are going to be good at it become elegant quickly, and those that are not are very mechanical. It's kind of like me. I can't play an instrument. I can mechanically play an instrument, but I'm not a musician by any means. Those coders that are really good are almost like a musician that is really talented, and you can see it in their code.
Yeah, it's interesting you say that because Bob is a musician, and when we worked together, his office was like the meeting room, and he had the guitar in the corner. But I mean, Bob, I want to throw it back to you. And what's the correlation that you see between kind of music and development?
Yeah, that's actually a really good observation because back when I was in college, one of the research papers that I did was I noticed a high correlation between the really proficient programmers that I hung out with and the fact that they were all musical in nature. So I kind of did a little bit of a study on it and found that there was a really high correlation between people who are musically inclined and people who are really good at developing software, and kind of dug into that. And I mean, what I determined was that music is a lot like software development. It's a set of it's a set of words, rules, syntax that in and of itself doesn't really define anything. But when somebody takes those rules and notes the chords and the structures, then you can pretty much develop or create anything. All the music that we hear is created from that same set of notes, rules, and constructs. And programming is exactly the same thing. You get, no matter what the language is, no matter what the syntax is, the logic is always going to be similar, and you're just able to create something using those set of tools. And I mean, really, they're the same thing. That's what it really comes down to, is you find that music and programming come from the same core, and that's just being willing to operate inside of a set of rules like that and create something new from scratch, and that's the correlation.
Well, one of the things we want to do with this show is what I call crack the telecom code, in terms of telecom is a complex environment. And so I'm going to throw back to Eli here and say, Eli, how do you teach software developers the telecom world?
That is a great question. I was thinking about this driving in. I remember being in Missoula, Montana with Stacy Harris and Brenda. This is a team that I led, and we were developing code for a project in the Middle East. And it's so complex. So we literally would have to sit there and just have week-long sessions explaining how the equipment and how a foreign key relates to a piece of a port that's a virtual port versus a physical port versus the backplane. It takes dedication from the architect, from the managers, to want to explain that, because you can give them an instruction set, or you can explain how the piece of equipment and the overall architecture comes together, and then that developer will just come out with solutions you didn't expect. So it really takes you taking that information, that telecom, whether it's a router, whether it's a switch, and it could be a crossbar, something that old. There's still some of that out there. So you want to help them understand, and then when that coder says, oh, that's an object, this is a subroutine function, they'll start developing that. But it really takes weeks. And really before they become really good at it, it takes years. And that's what requires a manager to take a long-term view. 18 years, Bob, I think you said you've been with that particular partner. By that time, you're almost thinking alike. Now, I have some that I've hired 5 times. And because as an architect, as someone who's setting the strategy, you want that, but then you want to keep bringing new ones in constantly. And that just takes a lot of dedication in teaching them. Have racks, literally, have racks right there with the programmers and no, see, when you do that, it turned this light on. And the reason that light turned on is because it's not working.
Yeah. And so, Bob, what are, back in the day when you and I started at CLEC, there were not REST APIs, there weren't XML interfaces, and we were doing flow-through provisioning to DSL chassis and connecting to our customer database and product catalog. What were some of the things that you've adopted, some of the techniques you've adopted to bring us up to speed on telco?
Well, I mean, it was the Wild West back then. I mean, there was nothing was easy, and every hardware provider was operating under a different paradigm, right? So, I mean, they all had their philosophies about how people should interact with their devices and control their devices. So, I mean, quite literally, it was the Wild West in the beginning, because you just pretty much had to make it up as you went along. Now, I mean, the common thread between myself and the people that I've worked with over the years is that we just have an insatiable curiosity. So for us, it was just a lot of fun to take these new devices and figure out how they worked in a short amount of time, and then, and then put them to work by actually controlling them. And we almost never followed whatever the engineering specifications were for anything. I mean, we learned a long time ago that we can make things do way more than the engineers that designed them felt like they could do. So, and operating in that kind of an environment, you just learn that the rules are kind of whatever you make. So, we tried a lot of things that in the end worked out great. We were able to do what looked like magic at the time. And it was mostly because, again, just like Eli was talking about, we were sitting around and we were figuring it out on the fly. I mean, but I mean, and it was working through things like simple network management protocols and other things that those devices use, but just getting creative with how we tie
the late 90s, and when the wireline world was going from TDM to IP, and maybe of your experiences with software development in the telco world, and then we'll do the same with Eli.
Yeah, I mean, it was an interesting time because the IP world was just starting to kind of work its way into telecom. As we built ATM networks, and we had built a lot of frame relay networks, and then put IP over the top of those different protocols, and so that was pretty standard fare. But then it got to be pretty interesting because a lot of the hardware started to be designed on platforms or on hardware platforms that basically were had operating systems like Windows or Linux or specialized operating systems like that, and then it was all IP based. I mean, it was clear it was all going that way. So a lot of our work at Expedius at the time was interoperating with IP, with those pieces of hardware, and creating an ecosystem that will allow for flow through provisioning. So as we've gone along, things like the soft switches, voice over IP kind of evolved out of the DSL world into a pure IP play. And then there's, again, fiber. You remember the fiber glut that was, there was a tremendous amount of fiber put in the ground because everybody thought more strands meant, that you were going to be safe. And then right on the heels of that, hardware came along and turned those single strands into what was basically logically multiple strands. And so you had all this. So at the point where you had the ability to have a lot of bandwidth, and a lot of manufacturers started building equipment where it took advantage of just pure IP transport. And that's kind of how it's evolved since then. I mean, just about everything's gone to, software platforms that have REST APIs and, interfaces that you can grab from any other web service and combine those into finished products. And you see that all the way down to the mobile platforms that we're working on today. I mean, it's continued that modularization and compartmentalizing these functions and what are basically web services and that you can attach to is all the way down to the mobile platform level. And then it's what we use today. I mean, that's what we use when we write on mobile platforms today. We're usually pulling a lot of information over the network, over an IP network, to give you the look and feel of an application that solves your business problem. So that's how it's all evolved, and it's going to continue to evolve that way.
Well, Eli, let's pick up circa 2000, when you and I were part of a founding team of a DSL company, right. and we started in December of 1999, and we had a mandate within 6 months to turn up the first of 40 markets.
I remember.
And literally there were 25 of us that quit our jobs and started this company, and we had nothing.
Right.
Walk us kind of through your experiences in the eyes of that company, and then you went over to El Paso, and more recently with Net Exchange, kind of the evolution of development through your experience.
Sure. Well, I mean, when we were doing the DSL launch, everything was point to point. It was circuits, it was ATM, everything had a fixed point, everything had a fixed address, and it was nailed down. I mean, it was still virtual, you had frame relay-like circuits, but they were nailed down. By the time we got to El Paso Global Networks, that had completely changed. You know, the IP world was fully vetted, things were being developed for Ethernet and IP. And when that decentralization happened, because that's really what IP does, it allows you to have a node anywhere, they don't have to be right next to each other, and now you have any kind of circuit that can just have a name, and that's what DNS did. You know, and today most people don't realize that what we're punching in, even if you're punching in an IP address, it's not the end destination, it's being resolved somewhere. Now on LTE, everything is IP. So what used to be a blade and the blade next to it are now servers. And now it's all being talked over by, like was being mentioned, some kind of XML interface, some kind of IP interface, but it is all data. Everything, all this, if you go through the 3GPP standard for LTE, what you're really reading is here's the functionality and now how it's developed in software and how an X11 or pick a name. There's S interfaces, X interfaces, E, and they all have a reason why they're called that. But it is still a bus with data, no more circuits. And then now the evolution of, you know, network function virtualization, NFV. It has taken it to a new level. Now we have the hardware on some kind of AX or X86, some kind of virtualization on top of it. Then the operating systems, VMware, or some kind of virtualization, and then the application on top of that. It is now servers. We no longer have a lot of technicians. We have literally Unix or Linux administrators that are working on servers, and there is an application on top of that that is a network function. That was what Bob was alluding to, you know, those modules that are now software. And now we're taking it to the next level, code as hardware. And that's where the coders come in. I mean, you used to have an electrical engineering degree to do some ASIC, you know, application-specific IC. Now it's a coder writing software inside a Linux virtual environment, and what used to be a piece of integrated circuit is now code. So it's code as hardware. And if you're a coder, you're a developer, we're at the beginning of the very launch of a new era.
Yeah, it's interesting. We lived through the wireline TDM to IP transformation, and we're going through that today in the mobile world. But what's interesting to me is that you can't open the web or get an email without somebody talking about a hackathon or a code fest or whatnot. And we've got another video clip that I'd like to run if our team's ready. And I'm going to let it speak for itself, and then we can talk about when that was played and when it was developed. So Stormy, why don't we go ahead and run the next clip.
Developers, 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 developers. Yes!
So, you know, I love this clip because, that's certainly an enthusiastic guy, but that was shot, you know, mid-2000 era, and as you may recall, Microsoft was, they kind of missed the internet revolution, and I remember Gates came out with a white paper, the Internet Manifesto, and tried to turn Microsoft on a dime because, you know, they were packaged software, the internet was in play, and they're almost at the same period today in terms of mobile, and they've had to take some drastic steps. But my point being is you know, where are we today in terms of software development, and you know, why is everyone trying to reach the developer community? And Eli, let's maybe start with you, and then we'll switch back over to you, Bob.
I think I touched on it. Everybody needs to reach out to the developers. It is what is driving the industry. Software is literally driving everything. As I walked in, I noticed that you have Z-Wave door locks. I mean, I have Z-Wave door locks at home. I have 98 devices that are connected to my home network. There is a developer that has written code for something very specific, whether it's for my coffee machine, which is connected, or the refrigerator, which is connected, or the microwave that's connected. So the developer is now going to become, or has become, the most valuable asset in a lot of organizations. Now, in the telecom, they are premier because the developers are manipulating the soft switches. They're manipulating the software that is now driving. Recently, Brocade released a new router at a cost breakpoint that is amazing. And it's all software. And it is a full-blown router. Now, we all know OpenStack, Cisco's in it, Ericsson's in it, everybody's in it, because software is now going to be the new hardware.
Bob, kind of your thoughts on where we are today and what it's going to be. What are some of the challenges over the next 1 to 3 years in terms of connecting with the software development community and then unleashing the power of the software development community?
Yeah, I mean, the interesting thing is if you go and look at the statistics about how many people are actually taking up computer science as a discipline, what's interesting about it is the rate of people that really hasn't changed proportionally over the last 10 years. I mean, the people who are interested in that are still interested in it, but it is not proportionally, there's no expansion happening with the supply. So I think the really interesting thing is that no matter how old you get, if you really know how to make things happen on a software platform basis, you're going to be in demand for a long time. So it really is it's a good time to be a programmer. But Eli's right. I mean, that's how this. I mean, it's all virtualization. It's all using hardware clusters. It really is gone and completely away from specialized hardware. Now they're using everything they can that's already there. I mean, when you look at the amount of horsepower that's in a mobile phone now, like I got a Samsung G4. I mean, when you look at what's in that thing, it's a multi-core processor with gigs of memory. I mean, our first phone switches didn't have that much horsepower when you really look at it. So when you have platforms that are pretty much in 65-75% of people's hands now, it has more horsepower than what we were using when we were trying to do our run a company. It just gives you a platform to work off of that's just got all that you need to make it happen. So again, I think that's why we're seeing everyone concentrating on things like APIs and development of those, and then opening up those environments. They don't have a choice. If they didn't open the environment up, the community was going to open the. So that's the reason Cisco's involved, is because that train has left the station. So I mean there is no two ways about it. If they don't, you're either going to be on the train or in front of it, and you know how it ends in both cases. So from our perspective, working and developing talent is going to be a critical piece of any company, whether you're telecom or not. It doesn't matter. We haven't even scratched the surface of enterprise, enterprise mobile systems, right? I mean, we haven't even cracked that shell yet. It's such a big elephant that it really hasn't even been scratched yet. So things like telecom are even in more of an issue like that. So, and you can see it in things like Twilio, which is kind of a company that allows you to more or less build your own CLAC out of components, which Eli I know is going to talk some more about that. But I mean, in reality, every piece of processing that you need to do the work of a telecom, you can get from somebody now in a cloud format, and that's just only going to continue to expand. So people who know how to connect those dots together efficiently are going to.
Man, I have to touch on something Bob mentioned. When he said that it is in that device and now it needs an API. First thing I do as the senior vice president looking at technology is thank you for the technology. Show me how I'm going to connect it. How easy is it for me to interface to your systems, and how open is it? And if I'm having to develop in some cryptic language because they haven't developed an XML, they haven't a fully baked API, I'm sorry, we're done. Because the total cost of ownership for that device, I don't care how good it is, it's going to be too expensive, and then I'm going to dedicate resources that could be better focused on something that is going to create greater revenue. And then Roger Hutton, who is the CEO, is going to say, why are you spending time on that? It's not show me the money. If it doesn't show us the money quickly, it's not going to get used. And that's what the cloud is doing for us. I mean, it allows us to develop and say, okay, I need to scale. You know, one of the new buzz is elasticity. Okay, that's great, but all that means is we need to grow quickly, and when we're done using it, shut it back down.
Yeah.
And all that requires APIs and northbound and southbound interfaces that are fully defined and easy to work with.
Well, why don't we, I'm going to get to a couple specific examples now. Eli, you're Senior VP of IT and BSS OSS for NetAmerica.
Yep.
Tell us about what you can tell us about the platform you've built, and because it does tie into something that's very relevant today, which is NFV and platform virtualization. So what can you tell us about
Sure.
the NetAmerica platform?
So one of our charters is to look for ways to reduce our cost, obviously, and the competition is stiff. So what we're doing is we have some private clouds already, and you always start
back. What is NetAmerica?
Okay, well, NetAmerica.
Yeah.
NetAmerica Alliance is just that, an alliance of rural telecommunication companies who had spectrum, and they had the ability to set up cell towers in their geographical area, and it may be out in the very rural Colorado Valley, Big Bend Telecom. You know, these individuals are out there, and there's no one serving that area. I mean, if you go out to some of these areas, you go back to literally on your phone, it says E. Well, if you don't know what that is, it's not fast.
And so they're trying to deploy LT, and it's too small of a market to invest in their own EPC of all packet core, and you guys are providing hosted solutions for those guys.
Exactly. So what we've done is created a centralized core, and millions of dollars, LTE core. We are using, and this core is now shared, so we have to virtualize it, and we have to develop the systems that allow each carrier to have full visibility to their systems, but still isolated. Virtualization is perfect for that, and that's what we're doing. You know, so we've created the front end systems where there may be a central core, but as far as each of our carriers, our alliance carriers, they see it as theirs, and it's flexible. And you have to be able to have it to where they can develop products, because what's good in Oklahoma is not necessarily identical in Colorado Valley, here in LaGrange, Texas. So we have uniqueness. So how do you build a provisioning system that does one thing for one individual company and does something else for someone else? And it has to be flexible. Texas Energy, you know, they're going to be going into the oil market. Are they a traditional play? Absolutely not. But we have to develop products for them.
But they're still a mobile operator chasing a vertical market that has to have all the same HLRs, Evolved Packet Core, policy management.
Absolutely. But it has to be flexible. Now, if we were using a traditional play where we had to have an engineer go develop a complete platform to be able to support a product, it would never happen. It would take years to develop that. But now it's all on a virtual machine. It's front-ended.
All Linux servers?
All Linux. So it's amazing, even some Spark. We still have some of it. Sun is still out there, and Oracle is still out there, so we use Spark. But it's all software-based. You know, the traditional Class 5 switch, everything's dedicated, a card for everything, it's gone. It's all software doing something. And that's really what we're doing. So we're building those front ends, and as we move forward with other huge projects that can't really disclose, we're moving not only from a private, but looking into the public cloud. Now, you still have to secure it, but it allows us to grow quickly. And those have the elasticity to be able to move from one place to the other quickly.
What were some of the specific software challenges and development challenges you encountered, and how'd you overcome them? That's
a good question. A developer has to be groomed to learn how to deal with a virtual environment. They're very used to, I'm talking to this box, I'm doing this box, and this box is always going to reply to me. But when you start using load balancers, and these systems are replying and say, no, it's not just one database server. Now it just grew to 3 or 4 or 5 because all of a sudden the data traffic requires that. You have to change the code. It has to start being smart enough to say, well, now I'm talking to box database 2, database 3, 4, 5, and know that. So you have to start thinking in parallel, not synchronous, not asynchronous, but parallel. And that's a very different environment. So you have to invest a lot of time in teaching them the platforms. You're going to have to pick a platform. If it's on the cloud, which one? You know, are you going with Rackspace? They have some really nice ones. Are you going with Amazon, AWS? But you're going to have to learn that platform and then leverage it. So that takes cycles. So you have to pick a small project. Do not jump in the dip in the pool with this one. Pick a small project, develop, grow, maybe do a private cloud, then look at to move out. But it takes time, and it's a big challenge because you have to change the overall architecture of how you develop.
And Bob, you were Senior VP of Operations for Global Star. Maybe walk us through some of your challenges and experiences building that platform, and how did the software development cycle work its way into that network?
Yeah, I mean, that was a satellite network, so that was the we actually built and launched satellites and more or less created a cellular network that orbited the Earth, with a 40 satellite constellation. So that was kind of the ultimate as far as telecom goes, and it presented a whole different set of challenges as it relates to latency and what you could do and what you couldn't do. And besides just voice and data connectivity, one of our biggest money makers was telemetry, which the Spot business, which was a personal device that you could use to track yourself. This was 8 years ago at $140 price point, right? So I mean, that was unheard of to be able to kind of be able to be located on the planet in just about any landmass for $140 and be able to press a button if you got into trouble and be rescued. So all of the development over that network was a result of need to be able to produce a unique product set that filled a particular business problem, which in this case there just weren't any really good, inexpensive GPS-based personal trackers for people. And that involved not only that was a really great project because it didn't involve just the hardware, but also the over-the-air protocols that were involved in that, as well as the back office that supported the customers end to end. So it was one of the few times when I've had to actually design a complete end-to-end system, both from the front end and the back end, because there was nothing like it. It was a one-off. There was nobody doing anything like that at the time. Still isn't anybody really doing anything like that at the same level. So, but the development of something like that was a lot more intense because in reality, you were plowing unknown ground and there were no models to follow. So, we were certainly, even at that point, we were doing things like clustering and virtualization. So we used every trick in the book as well. And then we also created our own REST APIs as part of the framework to expose to other users to develop code on top of. So, it followed, as Eli was pointing out, it followed some of the very same tracks that he is, and as it relates to developing a product for his customer base. This is exactly what we did. We consumed it internally and produced a product like Spot, which is where some of my patents were around that whole technology. But we also developed it in such a way to create frameworks that other people can take advantage of.
Well, gentlemen, we are out of time today. Thank you for coming up to Austin and visiting with us. And Bob, it's always a pleasure spending time with you. Did you have any kind of closing comments or add-ons to?
Absolutely. I want to thank Bob. Bob, I'm a private pilot. I use Spot. I feel secure when I have it, because if something happens out in the middle of nowhere, I'm going to push the button. Thank you for that, Bob.
Yeah.
Great. Well, thank you all for joining us today in Coders, and look forward to having these guys back on future episodes. Bob, Eli, thanks for your time.
Thank you, Jeff. Appreciate it.
Thank you.